going to do off of page 41, and we're going to do question number 3. And so in this question, they give us a combustion for propane, and we always have to start with a balanced equation. You guys, on a test, I'm never going to make you do balancing and math in the same question. If it's a math question for stoichiometry, I'll give you the balanced equation. If I want you to balance, I'll just ask you to balance. But I need you to practice that because we haven't had a lot of practice in balancing in a couple of days, and so we're going to practice it in our workbooks. It starts with propane, C3H8, and it's going to combust it, which means to react with oxygen, and all combustion reactions produce carbon dioxide and water vapor. Now this is not balanced, so we're going to balance it because nothing works unless we do. So 3 carbons before the arrow and 1 after, so I'm going to put a 3 here to get 3 carbons after. 8 hydrogens on the reactant side and groups of 2 on the product, so if I times that by 4, I get 8 hydrogens. And then 3 times 2 is 6, plus 4 more is 10 oxygens, so putting a 5 here gives me 10 oxygens. I don't have to write the 1, but just for a placeholder, I'm going to put it in right now. The balanced equation is required to answer all questions. And then, guys, we're going to label this. Like always, I said, look for the number they gave you. And this number they gave us this time was 5 moles of carbon dioxide. So the number I have is carbon dioxide. And the amount that they gave me was 5.00 moles. And it asked me 2 questions. It says how many moles of oxygen were burnt. So they want to find this question out in moles. That's the first question. And it says how many moles of the other product are produced. They also want to know moles of this. That's the second question. So I'm going to call this question A, and then I'll switch to purple, and I'll call this question B. And we actually have to solve those separately. Okay, we can't solve them at the same time. It's actually 2 questions. Now, I'm going to draw a little pathway, and this pathway is going to tell me how to solve my problem. The pathway is going to go from what I know, which is the carbon dioxide, to what I want, which the first thing I want is the oxygen. So I'm going to go here to there. Sometimes we draw them forward, sometimes we draw them backward. It doesn't really matter. It's from what you know to what you want. And I'm going to label this pathway up because this pathway is actually kind of a tricky thing. This pathway is actually what this little Y diagram would fit on. See how the Y diagram fits right on the corner? And then I could spin it, where the end points of the diagram would be things like liters, or mass, or the number of particles. But the corner point of my little green line there is moles. I know moles. So on this corner, I'm going to write what I know, 5 moles. Always moles goes on the corner. And it's the same thing here. If I want to solve for moles, that will be on the corner. If I was asked for liters or the number of particles or whatever, I could rotate this Y diagram to get to that answer. But again, I was only asked to find moles. So this is a 2-step conversion from moles to moles. I only need 2 corners. I didn't use the endpoints. So my factor label line gets 2 sections. The example in the video that we have has 4 sections. So, just like always, start with what you know. This is the number they gave me in the question, and that's what I know. So I'm going to write 5 moles, and I have to specify what I'm talking about now. We've been getting away without it, but we're going to talk about more than one thing, so I'm going to have to be very specific. 5 moles of what? Well, I'm under carbon dioxide, so I'm at 5 moles of carbon dioxide. So this was your starting point. Now, just like always, the units that are here in this upper corner always go down and to the right. So just the words moles of carbon dioxide are going to go down here. And where am I going? Well, the next thing that I'm trying to get to is right here. Again, corners mean moles. And it's moles of, I'm under oxygen, so moles of oxygen. Now, this is new. This is a new truth. It's moles on top and on the bottom. And when we have a moles to moles comparison like this, the only thing they have in common is the balancing. So now I go to my balanced equation, and beside carbon dioxide in the balanced equation is a 3, so beside carbon dioxide here I put a 3. Beside oxygen in the balanced equation is a 5, so beside oxygen, I put a 5. When we have moles on top and on the bottom, this is the only time you might put a number other than 1 beside the word moles. This is also the only time you will ever use the balancing numbers. It's the whole reason you learn to balance. So having said that, moles of carbon dioxide on the top cancels the words moles of carbon dioxide on the bottom. We're left with moles of oxygen. So mass goes 5 times 5 is 25 divided by 3. That gives us a value of 8.33, and the only units we haven't canceled are moles of oxygen. Now this was a really simple one. This question only involves 2 steps on this little picture. And honestly, folks, drawing this little picture here and labeling it up will always let you set up any question in stoichiometry. There are lots of examples in the stoichiometry video. There are ones where I give you grams, which you change to moles using your molar mass. Use these balancing to go to moles and then to grams, or liters to moles to moles to liters. You can practice 2-step and 3-step and 4-step conversions. So at this point, I know that some of you have seen the video and some of you haven't. This is just one more live example that I'll post. Watch the stoichiometry video. Watch this one again if you need to. Go through the stoichiometry video and look at the Tyler DeWitt ones underneath it, okay? And try a few. And when you come back next class, we will do lots of them together and we'll give you more time to work on it.